Hello YouTube, welcome to the Solistream. It's Half-Life 390 here again. You may be wondering why we haven't put any videos out yet, because a few videos back I said we'll be starting the Solistream with game reviews and things. We're working on Haunting a Hairbrine 2 at the moment, so as soon as that's out, in either December or early 2014, we'll get started on the Solistream for a fresh new year and start doing some videos. But right now, I'm just going to do a video on my CPU in Redstone, which I actually started on about a year ago, a year and a half ago even. I know it sounds like a long time, and actually it is. I made this CPU probably at most a year ago, and I never got a video out of it, which is really a shame because, like I recovered the old Starship I made on a different server, I had this just gathering dust in my single player world, and I never put it to good use, and to showcase or whatever, because this is a really good design I've made. So I've decided to bring it back up and make a couple of videos of it, just to show you what it is and what it does, and that it does work, and that I finally did finish the project. If you don't believe me, you can actually go and look back at my old videos and you'll see some really early videos of this. Like none of this was here, it was just a big empty box and there was a few screens and things. I'll put them links in the description actually. But I just want to, this video is just going to be a quick overview, a quick tour of the whole thing. This used to be on the server world, my server. So actually what I had was a Redstone school where I'd teach people Redstone on the site of the CPU so they could see it getting built as they were learning, basically. So, quickly go over here. This is just an adder example of how adders work, and a little display register. This isn't a part of the CPU. This is all the CPU though. It's almost like a C shape going round there, round here, round back to here with the 5/7 seg decoders screens there. Here's just a few specs of it. So it's a 16-bit CPU, 16-bit ALU that does add, subtract, and or XOR not and random number generator. No bit shifting or rotation, because at the time I didn't really know how I was going to do that. 5x7 seg to screen, 7 seg screens, that's there. And it's a decimal output, not a hexadecimal, because I don't like hexadecimal. So decimal output, 8 programmable lines of code, and 12-bit instructions. There are all the control bits where you can input. 4 bytes of RAM. It has a program counter that allows you to branch. I'm not sure actually whether it's unconditional or conditional, because I never actually worked out the difference between the two. I know what it is, but I never managed to match the name with the word. But let's just say it can't take it upon itself. I have to physically put a torch in on which line of code I want it to branch to and when. 16 ripple carry adders, that's the type of adder, so basic adder, because I don't really mind it being too slow. I mean, it's pretty fast, it's really fast actually. But that's why I don't really care about getting all custom built fast adders or whatever. It has a manual clock input where you just hit the button for every time you want a clock pulse for the moment, because an auto clock, I was getting problems and I needed to do some debugging and I didn't have a wait command, so I could never pause on whatever I wanted to do. So when I do have a clock, it can probably do something like 0.5 hertz, maybe once, 1 or 2 codes a second, or I don't know, 1 every 2 seconds, just to be safe, because it does have some timing issues that I wouldn't want to quickly, if we keep pressing the line of code, it will error out. CPU has 8 bytes of total memory in the form of registers. It only has 2 proper registers, which is the A register and the B register there. Registers are made out of mostly cobblestone, but it does have a U1 and U2 register, which are registers that the user can directly input to, even without needing to write a code for it, which is very useful if you want to get some values into the CPU without wasting lines of code. Those can't be written to, as I said, by the CPU. They're user input. Only the A and B register can be. Yeah, that's what I just said there. There is also a 16-bit / 2-byte output register, which is there, for storing the number that you calculated. So whatever addition, subtraction, whatever sum you do, the output will be on that display register and this screen here. Before I had the screen, I just used the display register, and that it acts as memory as itself. That will remember the number. And finally, this screen actually also acts as a register, I guess, because it remembers the number even if it ceases to be on the bus. It doesn't work. The screens don't work. Very unfortunate. As I said, the CPU is not very old, but at most a year old from beginning of construction. So after so many updates, for some reason the screen just doesn't want to work. I think it might be to do with the piston system that works in there. It's not actually my design of GPU, how this screen actually works, so I can't fix it. But I'm not bothered because you can still do the programs and you can still get the output there, which is good enough for me. I really can't be asked to start re-editing this now. It's just awkward. Really can't be asked. So I'll just show you a quick tour of the CPU. That's the specs. Final thing I want to show you, not really as important, but these are all the opcodes. So like you have ALU opcodes, you have all these. I'll show these after I've done the tour of the CPU. But yeah. So first of all we have, I'm just going to fly for this. Here we have the program memory. This is where the program you write in gets saved to. It's pretty big. It's probably the bulk of the CPU. It's where your program gets saved, as I just said. Here we have a mux for decoding instructions and things, and another mux here. Over here we have the registers. There's only two at the moment, as I said, A register and B register. A at the bottom, B at the top. All the way along, it's all one register. And this is all the other register. I was going to expand the registers going up, but never did. These are all busing there, all busing for the addressing. All of this is a massive 16-bit bus. If we go down, here is the program counter with its 8 programmable lines of code. Here's where you come if you need to branch. The opcode for branching is literally just 1. And then you put your torch on what line of code you want to jump to. Very simple. And then those feed back into the program memory. That's all this below section here is the program counter. Sorry for the lag, it is a laggy world. Over here we have, these are the U1 and U2 registers. These are vertical instead of horizontal like those. So when you manually input values, you can get them here, and then when you output, they activate a piston gate that puts the value from the register onto this massive 16-bit bus here. And that's just a lot of delay getting it on, but most people look at that and say that's a long delay because of how many torch changes there is, but in realistic it just goes pretty quick, and I don't find that really that long. But when people want to make ultra quick CPUs, they probably do. So all that's the CPU side. Now we come to the ALU side. This massive thing along here is the ALU. It's my own design. It's pretty big. It's a 16-bit ALU, and I call it the multi-story ALU because it's almost like a building, and at each story it does a different operation. So down here at the bottom we have the add and subtract units. That's just adders with, I think these are X and OR gates or multiplexers or something. The 2's complement. Oh yeah, by the way, it can't do negative numbers. I could expand it to do negative numbers, because all the systems here to allow that are here, but I can't be asked, as I said. ANDing, XORing, ORing, and NOTing. And this CPU also, whenever you enter 2 numbers, like from those registers or whatever, the operation is done to, every operation here is done to those numbers. It's only what's outputted is you select, if you know what I mean. So whether you want to add, subtract, whether you want to add and or a number, all of those operations are done at the same time. But whatever you selected to output from the mux here, this muxo decides what output you want. Finally we come over here, and this is the random number generator, all this system. It's just a series of clocks, and when you flip the switch to turn the clocks on, then we flip this piston gate, it allows the output onto the bus. Very simple. Over here we have, this isn't an actual part of the CPU, this is what I call like the V incline, because it's like a V and you have values coming out the ALU and then going up to the registers, then values going across to the output register and values going up to the decoders, so it's like one big junction, T-junction sort of thing. Yeah, here's the display output register. Once again, the mossy cobblestone, remember the 16-bit number, and that's the display register right below me there. And over here we have the screen decoders that don't work, unfortunately. So yeah, that's pretty much all of it. The last thing I need to show you is what this bus actually leads to. This is the massive 16-bit bus that gets the output from the ALU and brings it all the way back around to the registers. All the way back around here. Massive bus. So your output of your ALU can be saved to one of these registers. So you could do A register plus B register and save that in the C register if I had a C register, which is the annoying part. But there we go. That's the whole CPU showcased around here. This is the user input register. These just go to those user input registers over there. Just so I can show you the whole perimeter of this place. Sorry about the lag and the world generation. There's them there. And that's pretty much it. Now I'll show you the commands, the controls. I won't actually code it in this video. That's for a later video. I'll just show you all the inputs to it. Right, so over here we have the user input register's input. So you select a 16-bit number in binary here, and then you can either save it to the user input 1 register, the user input 2 register. Really simple. Just hit the button and that number is saved to those registers. Over here we have the control bits. These 12 bits control everything that the CPU does. So if you ever want to read from the register, whether that's the A register, B register, U1 or U2, or both A and B, or both U2 or U1, they're all inputted here. Reading from registers. Writing to registers, once again, you could write to the A register or the B register or both of them. Remember, you can't write to the U1 and U2 registers, so it can only do those three operations. And finally, we have the ALU controls, which control whatever the ALU does, so add, subtract, AND, NOR, XOR, all of that. The opcodes are here. So those are all the ALU opcodes, what you have to write in. Saving to registers, like I said, there's only 3 combinations, A, B or both. Reading from registers, these are all the opcodes for reading from them, and branching I'll get into in a minute. This control bank over here selects what line of code you're actually writing to. This is a good design because you can directly edit any line of code you want. So if you wanted to quickly go back and edit the 3rd line, you can without erasing any other lines. And what's this again? It's 8 programmable lines of code. This is the manual clock input. Literally just press that and that pulls the clock. This is where I had space to build the auto clock. Well, that one where I just flick a switch and the clock will turn on. Easy to do, just can't be asked. Right, here's the program counter, as I said, and for branching, literally all you need to do is do the branching opcode. That is just that. Actually, what line are we writing from at the moment? None. Right, I'll fix that. Yeah, don't want to make this video too long, so that's the opcode for branching, and then you select 1, 2, 3, 4, 5, 6, 7, 8, 9, which branch you actually want to jump to, and it'll jump straight to that branch, no matter what it be. And I've automatically got the last line, 8, to loop back to the first one, so it doesn't branch out of memory, because that would be pointless, wouldn't it? Right. Over here, we have the inputs that... great. This turns on the random number generator, so it's not always running, so it's laggy when it's always running. These are direct inputs to the ALU. I never use these because I never need to. This is where you can directly input an A number or a B number, and you literally just open the first line of code and select what mathematical operation you want to do. This is much easier, so you don't have to write a program to start doing things. you could just literally directly input it. But I never do that because I like writing programs. Otherwise I would have just built a calculator, wouldn't I? This is the output register, as I said, and that button just refreshes it. Final control, which is over here, resets the screen. But the screen's broken, so it doesn't matter. So that's it, that's my CPU, that's all the controls. That's just a basic, complete overview of what it is and how it works. In the next video, I will show you it doing some operations, some programming, and I'll also show you things like the Fibonacci sequence and stuff that you can program into it. Because it does have quite a lot of things you can do. Okay, thanks for watching guys, and see you in the next video. Don't forget to subscribe if you like it. You never know, I might end up doing a tutorial if people like it, but that probably won't happen. Okay, goodbye, and watch the Solistream.